I want to talk about some of the challenges we've been having in trying to overcome some significant data problems for understanding the world around us. And the problems begin by recognizing that there are two types of conflict that affect the course of nations. If you're thinking about the rise or fall of nations, conflicts between them, conflicts within. On the left side is wars between nations, right? Big armies, navies, and so on. On the right side is conflict that happens in a much smaller scale within nations. This is a picture from 1963 of a Buddhist monk self-immolating to protest the Republic of South Vietnam's policies towards Buddhists. These are two forms of conflict at very different scales, but they can have equally important and substantively important results. So if we look over the course of the last half century, from World War II on up, and we look at the number of major militarized conflicts all around the globe, in every country in the world, we see that the level of conflict overall, or the number of conflicts, has been rising over time. What very few people realize is that these bottom categories represent cross-country conflicts. The larger grayscale represents within-country conflicts, civil wars, and other forms of lower-level conflict that are very destructive. So most of the kinds of human conflict in the recent past have been gravitating towards within-country conflicts. We want to understand that because these kinds of conflicts are very lethal. So these are estimates of the global casualty rate, deaths caused by these militarized conflicts over time from 1946 to the late 2000s. And there have been a lot of people killed in these conflicts over time. If we disaggregate by the two types of conflicts, it's a complex pattern, but you'll see that more people are getting killed today in these within-country conflicts than in the between-country conflicts. They're becoming rarer. The within-country conflicts are becoming more lethal. So back to our two types of conflict. Well, it turns out there's a data problem that's wrapped up in trying to understand these conflicts. And that is that the cross-country conflicts are very loud. They make a lot of noise in the world system. Governments talk to one another. The international news system courses with information about them. It's easy to document that they are starting, and they have ended, and so on. The other kinds of conflict are very quiet. And it's often very difficult to even know that a protest has happened if you're not located in the local area where it has occurred, where there's some informational coverage of that kind of conflict. So, for instance, when Condoleezza Rice, in the opening days of the Bush administration's rollout of its plans to invade Iraq in 2002, when Condoleezza Rice gets on TV and says what she needs to say, there's a great deal of information about exactly what that means, the consequences for other countries in the world. But when this lady gets up and wants to have her say on things as well, we're much less likely to hear about her or why she's doing what she's doing or what cause she's advocating. We don't know. She's angry, we know that. But we wouldn't even know that if we weren't located in some level of physical proximity to where she was most of the time. So how do we find out about these various kinds of conflict? Well, through the news. But the news presents particular problems for trying to trace the ebb and flow of these conflicts, particularly the lower resolution within-country civil unrest kinds of conflicts, because of the problems that Dan introduced in his presentation. This is unstructured text. There is a great volume of it, and it's very difficult to pull out just the kind of information that we want to pull out about these small-scale civil unrest events in order to generate a larger picture of what's going on in the world, how they're happening. So the Cline Center for Democracy has, over a period of several years, invested a great deal of time and money to pull together a unique archive of global news coverage representing every country in the world. The top two sources are open source intelligence operations that have been run by the American and British governments since World War II. And we are looking at the most recent components of these two. These are setting up listening stations in every country in the world, translating news broadcasts from those countries at a very local level into English using native speakers of whatever languages are in these countries who are culturally resonant with the country, translating that into English, bringing it back to Washington, D.C. It's used for short-term intelligence work and then probably largely forgotten. So we've been pulling this together as a data science problem to try to extract the information that we'd like to know about these civil unrest events out of this huge volume of news data, and not just textual data, but we're also dealing with the historical records of these open source intelligence operations that are on microfilm and microfiche images, and we've got segmentation problems and a lot of other challenges to overcome. I'm going to be talking today out of a data set, a demonstration data set that we pulled together out of the entire population of news stories in the New York Times from 1945 to the mid-2000s. And so when you've got volume of data on the scale that we're talking about, the next question typically, if you've decided to analyze it, is do you use machines or do you use humans to do it? And the social sciences have been wrestling with these problems for quite a long time. In fact, the first efforts to use machines to work with unstructured textual data in the social sciences were back in the 1960s. And so there have been lots of efforts to try to see whether machines or humans can do a better job on problems like this. We aren't, at the Cline Center, coming out on one side or the other. We see machines and humans as having relative advantages. Okay? And so the machine-based systems, the kinds of systems that Dan was just talking about for us, are very good at processing a large volume of data quickly and accurately, but processing what social scientists would call manifest content in that data. So manifest content would be an example of does the word demonstration or protest or strike appear in a news article? It does or it doesn't. A machine is going to process that question using a rule set or any other way that you want to choose much faster and more reliably than a human will do. The humans will be good at the beginning, but they're going to get tired, need a coffee break, and so on, and they're going to lose accuracy. So machines are very good at processing manifest content. Humans tend to have a relative advantage in processing latent content, where the meaning is not just right there in an obvious yes or no checkbox fashion, but along the lines that Dan Roth was discussing. There's ambiguity, there's variability in the reference that could be used. But what's funny is even Inspector Clouseau can figure out these ambiguity problems that are taking Dan Roth's group into the upper stratosphere of research on trying to run this through machine-based systems. We're used to dealing with that kind of ambiguity all the time. The problem is we can't take that knowledge to scale that the machine-based systems could take. But the relative advantages of humans over machines, I think, can be summarized pretty succinctly in just observing that humans get the joke. Okay, so here's the joke. You ready? One person says, "My dog has no nose." And the second person says, "How does he smell?" "Awful," says the third person. Okay? And with all due respect to Monty Python, not only do humans get that that was a joke, okay, but we also get that it wasn't a very good joke. All right? It was a clever wordplay on awful. We get that. Machines would have a very difficult time. So we want to leverage at the Cline Center the ability of humans to disambiguate context very easily, because the context that humans bring to them and not dependent on just what's in the text, but to merge that with the scalability and reliability of machine-based systems. So we have been working on what we're calling a progressive supervised learning system. So you've probably heard about supervised learning systems, and the standard way of implementing them is you get humans to come up with a gold standard set of classifications. and you feed those gold standards to a machine system, you fine-tune it, you optimize it, and you come out with a classifier. So the human input is at the beginning, and there's an optimization process, and then you run the machine system from there. The system that we're employing is a hybrid system that brings humans and computers together interactively over time. And so this is a complicated diagram, but our process starts with having some repository of documents of news articles, which get fed into a classifier. And in this diagram, the circles represent just repositories or databases. The squares are automated machine-based processes, and the triangles are human-based annotation processes. So we send these things into a classifier that makes a decision for us whether this particular news article is likely to contain information about a civil unrest event or not. Is it relevant? Is it irrelevant? With the New York Times data, 85% of the articles are kicked out immediately, not relevant at all. 15% move on through our system. We then send that 15% through a series of natural language processing modules that extract entities, that identify dates, that come out to geocode any location references, and so on. That then, metadata, along with the original article, gets sent to a repository, a document store, out of which some subset is selected for further analysis and sent up to human coders who are equipped with machine systems in their interfaces. So this is through a web interface, and machine systems will, for instance, present a list of known entities of organizations and ask, is this particular event related to this entity or that entity, both of which show up, are named in the article. So the humans help to correct any errors that might be part of the machine-based process, but having the machine capabilities maximize the efficiency of the human coder's time with the article. Human coder ultimately discards some of these articles, no, they didn't contain any civil unrest event data, or keeps them, they did, and there's additional coding and annotation of those done by the humans that are not currently within reach of the machine systems to do. But then this is what makes this a progressive supervised learning system. We then take the output data that the humans have produced, and we send them back to produce new test train data sets to refine our classifier. And this can be done in pretty much real time as well. So our classifier gets better and better as we move on. But we also go back and correct out the natural language processing part of our component. Maybe an entity was given wrong or a date was extracted incorrectly, and we can modify those algorithms also in real time to be able to refine that thing. And so the idea behind a progressive supervised learning system is that machines do what machines can do best and do well. Humans do the subset of tasks that need to be done, but the machine capabilities are not yet at the point where they can substitute for humans. But the humans are trying to work themselves out of a job, producing more and more test train data to get the classifiers to operate more and more efficiently. Eventually we move the humans off to the next hard task that the computers can't do, and that is a progressive supervised learning system. So let me take you through some of the benefits that we've seen at the Cline Center in trying to come up with this new generation of civil unrest data, for which there is no central repository. There's no structured data set out there that we could turn to, so we have to get it out of the news. So one of the benefits that we get by bringing the machines and humans together in these processes is that we're able to measure for the first time the intensity of these civil unrest events. So there have been, for many years, several applications that are automated entirely that will count up whether some kind of civil unrest event has happened or not. But obviously there are differences between events, and what we find in our data is that the median number of participants in small scales giving a speech against